All right, welcome to 7-2. We're going to solve systems of equations by using substitution. So the very first thing I want you to think about is, what's the definition of the word substitution? Or what do you think about when Miss Senny needs a substitute teacher? So we're going to use that idea or that thought process when we're doing this. So hopefully you were thinking in your brain something like substitution means replacing something with something else. So what we're going to do is we're going to replace different parts of our equation to help us figure out the answer to our system of equations. This is really just a shortcut so that we don't have to actually graph our systems of equations every time, because we know that can be kind of time consuming and that kind of stuff. So let's go ahead and look at this first problem. We've got y is equal to negative 4x plus 8 and y equals x plus 7. Something that I notice right away about this equation is that it's probably a little too difficult for us to start off with. So let's go ahead and change this plus sign to a minus sign. I think that will make it an easier problem for us. So then when we go ahead, we think, okay, both of these things are supposed to equal y. Well, if they both equal y, wouldn't it make sense that I can take this equation right here and I can replace the y that's down below with the information that's in that equation? Okay, I'm hoping that makes sense to you. So what we're going to do, or part of our shortcut, is to replace that y with negative 4x plus 8. So I'll try to write that out the best that I can. Negative 4x plus 8 is going to equal x minus 7, because remember we changed that one part of the equation. Sorry about the email popping up there. Anyway, so now all we need to do is we really just need to solve our variable, or solve our equation for our variable of x. I like positive coefficients, so I'm going to go ahead and add 4x to both sides, but you know that you can probably also take away the x on each side if you wanted to. So when I add 4x, that kind of cancels everything out on the left side and leaves me just with an 8. And then I end up with 8 equals 5x minus 7. So then my next step would be to add 7 on both sides. So I'm going to go ahead and do that. So I get 15 equals 5x, divide by 5 on both sides. And hopefully you figured out with me, or hopefully you were following along, that x is going to be 3. Now that we have our x, that stands for our x coordinate. We still need to figure out our y coordinate for the system of equations. So we're going to plug the 3 in to one of our two equations up top. It doesn't matter which one you plug it into, but I always suggest that you plug it into both to make sure that it actually works. So if we plug it into the top one, it would be y equals negative 4 times 3, holy cow, this is really off center, sorry, times 3 plus 8. So when we solve that, we get negative 12 plus 8. So that means y is going to equal negative 4. So let's just circle that for right now, but then let's plug our x coordinate that we got into our other problem. The other problem was y equals x minus 7. So we're going to write y equals 3 minus 7. And the last time I checked, 3 minus 7 was equal to negative 4. So we know that we actually have the correct solution to our equations. So we would go ahead and write our solution to the systems of equations like a coordinate. Sorry, it was hard for me to write negative 4. So that coordinate, or that point, is 3, negative 4. Go ahead and take a minute, and why don't you summarize what you just saw me do?